I hope you have studied the statement of the definition of the integral several times and ruminated over it for at least 15 to 20 minutes. Let's go on to the proof. Let AI and BJ have a non-trivial intersection. That is, I am choosing one AI and one BJ and assuming that they have a non-trivial intersection. Okay. Now, basic fact from Lebesgue integral theory is that if a function is a Lebesgue integral on a set, Lebesgue integrable on a set, not Lebesgueable, I combine both words. If a function is a Lebesgue integrable on a set, it is Lebesgue integrable on any measurable subset as well. Automatically integrable on any measurable subset. Okay, so I'm going to use this fact in a moment. So we have to introduce notation. I have to apologize as it is, there is too much notation in this theorem, but we have to introduce some more. We have really no choice but to do this. Let's call AI to be omega I composed with phi I. So recall, omega I was the local coordinates of the form omega in the set phi I of ui with respect to the frame field determined by the parameterization phi I. And similarly, bj is omega j composed with psi j. Okay, now our assumption is that AI is integrable on Ci, right? That's our assumption. Now look at phi I inverse of AI intersect bj. We are assuming that AI and bj have a non-trivial intersection. This will obviously be a subset of Ci. Recall that Ci was just phi I inverse of AI. So phi I inverse of AI intersect bj will be a subset of Ci. Now observe that if we vary j, if you vary j across all the possible natural numbers, the sets phi I inverse of AI intersect bj will be exactly equal to Ci, right? Because the bj's cover the manifold M, so in particular they must cover the set AI as well. Okay, now denote by chi j the characteristic function, indicator function basically, of phi I inverse of AI intersect bj. Okay, so in short, what I said just before, that the union of all the phi I inverse AI intersect bj as you vary j is equal to Ci can be rephrased to say that summation over j chi j of AI is nothing but AI, right? So let me just slightly change the notation. Yeah, this is fine. Yeah, this is absolutely correct. When you take the sum of chi j AI, you would just get AI, right? These for this to make sense, you must first of all observe that phi I inverse of AI intersection bj are pairwise disjoint. That is one of the key facts, because bj's are pairwise disjoint, and this phi I is a fixed chart and it's fixed parameterization and it's injective. Because of all this, you get that summation over j chi j of AI is AI. Okay, and this is true on Ci. Recall that AI was defined on Ci. Now applying the dominated convergence theorem, dominated convergence theorem, we get integral of Ci over Ai is nothing but summation over j integral on phi inverse Ai intersection Bj of Ai. This is just a straightforward application of the dominated convergence theorem combined with the statement what we have written here. Okay. Now, there was nothing special about Ai here. In the previous conclusion, in this last equality, we can replace Ai by mod Ai as well, by mod Ai on both sides. It will still be true. Exact same argument, dominated convergence theorem will give it for you. Now what we are going to do is we are going to transform this Ai into a Bj. Okay, how are we going to do that? We have to do a change of variables. So some more notation coming your way. So keep your eyes open and your mind in full focus. Let omega be phi inverse of phi of ui intersect psi of vj. Okay, so we are assuming that phi of ui and psi of vj intersect because if you assume that ai and bj intersect, obviously phi of ui and psi of vj must also intersect. Okay, so this omega will be non-empty whenever there is a non-empty intersection here inside. Okay, now define this function f of x. This is just a temporary definition just in order to apply the change of variables. Define f of x to be ai of x if x is in phi inverse ai intersect bj and 0 otherwise. Okay, and let u be by definition just psi j inverse of phi of ui intersect psi of vj. Okay, now it is appropriate that I draw a bad picture so that we can have a good understanding. So this is the manifold M. You have phi I of ui and psi j of vj. These two sets are intersecting. What we have done is when you pull this back under phi I, this set we are calling omega. When you pull this back under psi j, this set you're calling u. Okay, we are going to transform the integral from here to here. Okay, we already have expressions for integral of ai here. We are going to transform it here by the change of variables formula. Okay, so what is the change of variables here to go from here to here? Well, to go from here to here, I just go from u to this intersection via psi j, then go back here via phi inverse. So define g from u to omega by phi inverse composed with psi j. Okay, what does the change of variables formula tell us? It tells us that integral over phi inverse of ai intersection bj, which is just omega. Why am I writing the whole thing? This is integral over omega of f is nothing but integral over u of f composed with g determinant of dg. Wait a second. Shouldn't it be an absolute value of determinant of dj? Well, the absolute value is not present. The reason is because both psi j and phi I are supposed to be coming from orientation covers. If you recall the statement of this result, both those come from orientation covers. And I had made a remark in the previous video that we will fix an orientation on the manifold M, and our orientation covers will always respect the orientation given on the manifold, which means that they will push forward basis vectors to basis vectors on the tangent space that are equivalent to the given orientation. And one of the exercises in the video on orientations was to show that if you have two maps that preserve orientation, then if you take this composition, the determinant of that should be positive. Okay, so it's rather easy to see that this determinant of dj will automatically be determinant of dg will automatically be positive because both of them come from orientation covers. Please check the details. Okay, now look at this pullback of the form omega restricted to psi j of vj. Okay, pull it back under psi j. So what I am saying is, so omega j lives here, omega j lives here. I'm saying pull it back under the map psi j. Okay, so restrict omega to psi j of vj and pull it back under psi j. Now these are top degree forms, so when you pull back you get top degree form. So call this pullback to be eta j, and this is going to be exactly bj of dy1 wedge dot 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 dyn. I'm just calling the coordinates on this set u to be dy1 to dyn, the basis vectors of the dual basis vectors. I'm calling dy1 to dyn. It's going to be bj dy1 to dyn y. This is better just pondered over, and essentially it follows because bj's were the local coordinates of omega j. That's the reason. Just think about why this is true. Excellent. So this is on vj, of course. Similarly, we can pull back the same form phi star on omega restricted to phi of ui, and this is going to be, I'm just going to call it eta I, and this is going to be ai, and calling the dual basis vectors on omega to be dx1 to dxn. This is going to be ai dx1 wedge dot 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 dxn. Okay, this is on ui. Okay, now the chain rule for pullbacks, gives that g star of eta j restricted to omega must be eta I restricted to u. This just follows because of the definitions of eta I, eta j, and the definition of the pullback and the chain rule for pullbacks. Okay, now here is the crux of the proof. But we already know that pullback of top degree forms is given by multiplication by the determinant. We have already seen this. We have proved this several videos ago when we analyze pullbacks to a great in some detail. So because it's just going to be multiplication by a determinant, this is just a roundabout way of saying that bj of y is nothing but ai of g of y determinant of dg of y. Okay, this is just a roundabout way of saying this. So what is our net conclusion? We have integral over phi inverse of ai intersect bj. F is nothing but integral phi inverse of ai intersect bj of ai. Because of the definition of f, it's going to vanish everywhere. Outside of phi inverse of ai intersection bj. Because of the definition of f, we get this. Of course, I am using change of variables. I'm using this. Okay. Coming back, integral over phi inverse of ai intersection bj of f is integral phi inverse of ai intersection of bj ai, which is going to be nothing but integral over psi j inverse of ai intersection bj ai compose which the determinant of dg. This is just the change of variables formula. But from what we have concluded so far, this is nothing but integral over psi j inverse of ai intersection bj of bj. Okay. Now the same argument works with mod ai and mod bj. Nothing special about ai and bj. Same argument would have worked if we had started with absolute values. Okay. Now because of this it's clear from the dominated convergence theorem, no need to apply even dominated convergence theorem. It's clear that summation over I integral of psi j inverse ai intersection bj of mod bj, this is going to be less than infinity. Okay, so technically what is happening is this expression comes from the fact that summation over I integral of phi inverse of ai intersection bj of mod ai is going to be less than infinity. But because we can shift over the variables, we have changed ai to bj, this will continue to be true. Okay, so we have this. Okay, which means each bj is integrable on psi j inverse of bj. Okay, now apply dominated convergence theorem. To conclude that summation over I integral of psi j inverse ai intersection bj of bj is nothing but integral of psi j inverse bj of bj. Okay, and again we can replace by absolute values. We can replace bj by mod bj above. So these fine details I am of course leaving it to you in the interest of saving time, plus you will have a better understanding if some of the steps are skipped and you work it out yourself. Okay, but the left hand side is nothing but summation over I integral of phi inverse of ai intersection bj of ai. Right, this is just what we have concluded by the change of variables so far. So what is the net upshot of all this? The net upshot is summation over j summation over j integral psi j inverse of bj is nothing but summation over j summation over I integral phi inverse of ai intersect bj of ai. Okay, now we are going to interchange the summation and write this as summation over I summation over j integral of phi inverse ai intersection bj of ai. Okay, and this is nothing but summation over I integral over phi inverse of ai intersection bj of ai. Okay, so what has happened is the summation over j phi inverse of ai intersection bj, one second, I made a slight mistake. This is just phi inverse of ai. The integrals, the summation of the integrals over phi inverse of ai intersection bj ai is just going to be integral over phi inverse ai of ai. Okay, and this finishes the proof. This finishes the proof. Now, one step that I have skipped is, why is it that you can interchange the summations? That's because we have already established that summation over I phi inverse integral ai intersection bj mod ai is equal to summation over I summation over j integral phi inverse ai intersection bj of ai mod ai, which is less than infinity. We have already established this in the course of the proof, that when you sum up in this order with the absolute values inside, you do get a quantity that is less than infinity. This is by hypothesis. We are assuming that summation over I integral over ci of omega I composed with phi is less than infinity, even with the absolute values. So because of that, this whole thing is less than infinity, and because of that you can interchange the summation. There's a precise exercise given in the notes which tells you that you can interchange the summation under this scenario. So the definition of the integral is indeed well defined. Irrespective of how you break up the partition, you get the same value. So this concludes the proof of well-definedness of the integral. This is a course on real analysis, and you have just watched the video on the proof of well-definedness of the integral.